Picture a truck stop right in the middle of the Mojave Desert in mid-July. It is 120 degrees outside. The asphalt is physically melting your boots. Right across the highway sits an air-conditioned motel with glowing vacancy signs. Yet rows of heavy-duty trucks sit parked in the blazing sun, and not a single driver moves. You might assume they are just trying to save $100. You would be wrong. A veteran owner-operator makes a solid living. Money is not the barrier holding them back. The real reason they stay trapped in a metal box baking in the sun comes down to strict freight contracts and a mechanical nightmare that most people never see. A semi-truck is essentially a giant greenhouse on wheels. When the outside air hits 120 degrees, the glass and steel trap that heat violently. Within an hour of shutting off the massive 15-liter diesel engine, the giant motor that pulls the whole rig, the interior of that cab blasts past 160 degrees. The dashboard alone can easily reach 180 degrees. That is not just slightly uncomfortable. That is a physical space where a human being will absolutely not survive the afternoon, so the driver has to cool that oven down fast. The easiest choice is to just leave the big engine running to power the air conditioning. But strict environmental laws, specifically the rules from the California Air Resources Board known as CARB, make idling that big engine completely illegal. They are forced to rely on small secondary cooling machines instead. But here is the brutal secret that nobody outside the industry understands. When the desert temperature hits 120 degrees, those expensive backup machines actively begin to self-destruct. By the end of this video, I will show you the exact physical trick veteran drivers build inside their cabs to stop their cooling systems from completely melting down at midnight. If you want to know how truck drivers sleep in their cab when it's 120 degrees Fahrenheit outside, you need to understand the mechanical trap they are sitting in first. Those environmental rules are no joke. Under the 13 CCR 2480-2485 regulation, a driver in California cannot idle their main engine for more than 5 minutes. If an officer catches a rig running just to keep the cabin cool, the first ticket is a straight $300 fine. If they get caught again, those penalties climb all the way to $10,000 per day. A truck burns a gallon of diesel every hour it idles. Between the massive fines and the burned fuel, leaving the engine running all night will instantly bankrupt a driver. If you are finding this hidden reality of the trucking industry interesting, take a quick second to subscribe and like this video so we can keep pulling back the curtain for you. Since the government forces drivers to shut off the main engine, the industry had to invent a clever workaround. They call it an auxiliary power unit, or APU for short. This is basically a tiny second engine or a massive battery bank bolted directly to the frame of the truck. Its only job is to run the air conditioning and keep the cab cool while the massive main engine sleeps. It sips fuel and it keeps the driver totally legal. It sounds like the perfect solution. But here is the catch that the rule makers completely missed. An APU actually works flawlessly on an 80-degree spring day. But a 120-degree desert heat creates a brutal paradox. The government mandates that drivers must use this exact technology to survive. But physics dictates that extreme heat actively melts the internal components of the APU itself. The truck's brain, called the Engine Control Module, or ECM, starts sensing catastrophic heat levels. What happens next immediately forces the driver into a truly dangerous nightmare. When that ECM brain panics, the electric systems are usually the first to die. Let us look at top-tier electric models like the Bergstrom Nighthawk Electric APU. The sales brochure promises 12 hours of quiet and perfect cooling. That sounds amazing on paper. But that factory testing always happens in a nice 70-degree room. Put that same rig in a baking desert lot and things change rapidly. The black asphalt underneath the truck radiates extreme heat straight up into the metal battery box. Those systems rely on a bank of absorbent glass matte deep cycle batteries, mostly just called AGM batteries. They are engineered to store massive amounts of electrical power. But these power banks have a hidden chemical weakness. When the outside air hits 120 degrees, the battery actually starts to cook from the inside out. Battery science shows us that for every 18 degrees above normal room temperature, the internal corrosion of the metal plates inside the battery doubles. The extreme heat forces the chemical structure into a state of thermal softening. This severe heat damage triggers a condition known in the industry as premature capacity loss, or PCL. The battery permanently loses its ability to hold a charge over time. So while the air conditioning compressor is screaming at maximum power trying to cool the cabin, the battery voltage drops like a stone. The computer senses this sudden voltage drop and abruptly shuts the entire cooling system down to protect the battery bank from completely destroying itself. This catastrophic failure never happens right at sunset. It always happens right in the exact middle of the deepest sleep cycle. At 2 in the morning, the cold air completely stops flowing. Within 30 minutes, the metal cabin becomes a dark oven again. The driver wakes up, drenched in a pool of sweat, completely trapped in the boiling heat. Electric systems simply cannot survive the baking desert floor. So you might think a small diesel engine backup would be the bulletproof answer. But the liquid cooling inside those small diesel versions hides an even more dangerous mechanical flaw. Those small diesel systems seem like the absolute ultimate fix, right? You would expect a tough diesel engine to easily handle a brutally hot summer night. Units like the Carrier ComfortPro or the Thermo TriPac are absolute workhorses in normal, everyday weather. But they have a massive hidden vulnerability. These secondary engines do not use their own separate cooling system. They actually share the exact same liquid coolant loop with the massive main engine block sitting directly under the truck hood. When you park the rig in 120-degree heat, no fresh air flows through the front radiator to cool that liquid down. The heat just sits there and bakes. But the real nightmare starts with a simple human mistake. Mechanics often use manual shutoff valves to block that shared cooling line during routine maintenance. If a shop technician forgets to open those manual valves back up before you hit the road, the secondary unit turns into a self-destructing metal box. You start the secondary engine thinking you are safe for the night. The machine runs perfectly fine for about 15 minutes. But because those valves are closed, the hot liquid cannot escape the tiny engine block. The internal temperature of the unit rockets out of control. The computer inside the unit immediately senses the catastrophic heat level. It triggers a massive alarm, usually flashing a code 18 high engine coolant temperature warning right on your digital dash. To prevent a literal engine fire, the computer instantly kills all the power. The cold air completely stops. You wake up in a pitch-black cabin that is rapidly turning back into a 160-degree oven. You are completely trapped between strict government fines and a broken cooling system. Your batteries cannot handle the heat, and your diesel backup just cooked itself. You cannot just magically fix a closed valve in the dark while you are sweating to death. You desperately need a manual physical workaround to force that tiny bit of cold air exactly where you sleep. And that brings us to the brilliant physical trick that true veteran drivers actually use. Even if your backup machine magically dodges that cooling error, you face one final invisible enemy. Basic physics dictates that cold air naturally sinks. So while your tiny machine pushes out cold air, all that freezing air just pools around your feet. The machine's thermostat usually sits low on the wall near the evaporator coil, the cold metal part that actually chills the air. The computer thinks the cabin is perfectly frozen. But since you sleep high up in the top bunk, you are still actively roasting in that brutal heat. Your machine keeps screaming at maximum power, trying to push that cold air higher. The compressor runs non-stop at 100% load. This extreme stress eventually blows the AC run capacitor, the small electrical part that starts the cooling motor. Once that part blows, your night is completely ruined. But veteran drivers refuse to just surrender to bad factory engineering. They build a brilliant physical workaround called an air tower ducting modification. You basically attach a physical vertical tube directly to the cold air vent and run it straight up to your mattress. This custom chimney forces all that freezing air exactly where you sleep. This simple plastic tube completely changes the thermal math. The thermostat reads the correct temperature quickly. Your compressor finally gets to cycle off and rest. You totally eliminate the strain on the machine and stop those midnight thermal shutdowns forever. You take control of your environment instead of letting the machine dictate your survival. You finally get the deep sleep you desperately need. But does this raw mechanical survival actually make your life better than a comfortable hotel room across the street? The final hidden truth of the open road will completely shock you, proving exactly why real drivers never choose to leave. You might look at that motel across the highway and think the driver is suffering in that metal box. But the reality is completely different. When you properly engineer your cab, you are not just surviving. You are mastering your environment. Running those brutal Death Valley routes in a Class 8 heavy-duty truck requires an elite mechanical mindset. Groups like the Owner-Operator Independent Drivers Association, or OIDA, know that true professionals do not just steer the wheel. They actively solve tough thermal problems that factory engineers completely overlooked. Picture that exact same truck stop at 3 in the morning. Outside, the desert asphalt is still radiating intense heat. Inside the cab, the custom air tower pushes a perfect stream of cold air directly over the sleeping driver. The expensive machine runs smoothly at a low cycle. The driver avoids those massive government fines, saves thousands in burned fuel, and sleeps in total silence. They are sleeping significantly better than anyone in that cheap roadside motel. They took a lethal environment and turned it into a custom climate-controlled fortress. But beating the extreme heat is only half of the modern trucking battle. You can build the most advanced cooling system in the entire world, but it means absolutely nothing if you cannot actually find a legal place to park your rig for the night. This growing crisis forces drivers to literally split their sleep into 2 brutal shifts. The video on your screen right now explains this perfectly.